So in this case, we are going to consider our coplanar forces. That is actually the use of components in resolving our coplanar forces. So we are going to be resolving using the components. So I'm going to have an introduction actually of how to use these components using the reference angle. Then you are going to have another class whereby you'll be using the actual angle. So this is important because as we'll be working with our engineering science, actually engineering science N3, you'll be working with forces. You need this part, engineering science N4, as you are working with the part of kinematics. There's a part that you're using components. So it's either you've got another method or you're using the components. So this part will be very, very important as you are working with your engineering studies. So the coplanar forces, we are simply referring to the forces that can act on an object that are in the same plane. So we are simply referring here to say these are forces that can act. So that can act on an object in the same plane. All right, in the same plane. So what actually happens is that we are going to be having the magnitude of that force and also the direction. So actually they have both. So these ones, they have, all right, so they have both magnitude. That is the magnitude and what? And direction. So they also have the direction. That is considering to say, we remember from your North Pole, this is your north, your south, your west, and your east. So you'll be considering to say, this is given as a force of maybe 50 Newton, then the angle is a certain angle that you are given going to the what? To the north direction. You are moving from the east to the north, or maybe you are moving from the north to the east. So it depends with what you be given. You are moving north alpha degrees going to the what? Going to the east. So this is the condition of the direction, the magnitude, that is one that you're given. So if you're in N4, you won't be working with the force direct, like I said in your kinematics. You'll be working with the speed. Definitely, you'll be given those velocities, which are in kilometers per hour, meters per second, whatever that you'll be having there, and the direction. So that is the part that actually you'll be having. So you need the magnitude and the direction. So when you are to resolve, because you'll be given different forces that are being taken at a point of application of what? Of the force. The point of application of the force is the point where we are taking our forces. All right. So we have this one as the point of application. That is the point of application, the point of application of the forces. All right, of the force. So be referring to a certain force. Whatever that we are going to talk about later on, guys, I want you to take note that as you are to make calculations, make sure that the force is being taken from the point, from, not to the point, but it must be taken from, meaning to say we are taking this to another way, something like this. From this point, that is how it's supposed to be like. So whatever that you are given that is facing the point of application of the force, it must be extended to the other side. If you're given a force like this, you must extend it so that it must be taken from. It must be from this point. So whatever that you're going to have later on in our calculations, that must be kept in mind. Whatever that you're going to have, it must be taken from what? From the point of application to wherever the direction that you be given there. So using the components now in resolving, I want you to get rid of these guys when you are referring to the components. What is it that you're actually talking about using components? And in our class, we are actually going to be focusing with the reference angle, using the reference angle. So the components that we are actually referring to are the horizontal and the vertical. Where is this one being taken from? We are saying if a force is being given from our point of application, let's say we've got something like this, okay? We might need, actually we'll need to determine its component, which is the horizontal and also the vertical, as we are taking it from this point, all right, like this. We are forming a triangle. So this side is our horizontal and this is the vertical. So you'll be having a certain angle, which is your theta, and this part representing our horizontal, representing the vertical. So as we have our trigonometry, guys, the part of forces, once we have this angle that we are seeing here, guys, we are supposed to know application of our trigonometry also. So this will be our resultant here. So remember from your trigonometry, guys, I want to be focusing with these two, the vertical and the horizontal. Remember from your trigonometry, this according to theta represents the opposite. So we have got the opposite here. This is our adjacent where we have got, because this is a right angle triangle. So where we have this line and this one, they meet at 90 degrees, okay? So the angle, that is 90 degrees there. And the side is what? Adjacent, where this angle and the 90 degrees, they lie on this line. They lie on this line, meaning to say they are adjacent to each other, right? And this is our hypotenuse. Always hypotenuse, the longer side, the one that faces what? The 90 degrees. So this is your mathematics, guys. Here, I'm not going to explain much. You recap your mathematics. So like I said, I'm going to be focusing on the vertical component and horizontal component. Remember, this is the part that we want to have here using the components, and these are the two. So relating to these two, let's start with the vertical, or you can even start with the horizontal, whatever that you want. So for the meantime, I'm going to remove this part. All right, I'm going to remove this. So the R there actually represents the force. So let's just take it as a force so that we do not have confusion for the sake of the resultant that we use later on. So let's say this is your certain force that you have, and you want to find the horizontal. We're going to talk about the vertical later on, don't worry. So according to the horizontal component that we have, we can see that we've got adjacent and hypotenuse. These are the two that you'll be given. The force that you're given and the part that you want to calculate, which is the horizontal component. So as we can see, guys, according to these two, because we are not having this for the meantime, we are focusing with adjacent and what? Adjacent and hypotenuse. Remember your mathematics. So actually, I'm not going to talk about this for now. I just want to talk about where we have got what? Horizontal and what? Vertical. But for the meantime, horizontal, we said we've got adjacent and hypotenuse. So adjacent and hypotenuse is on cos. Remember your ratio of a cos there from your mathematics. The cos of theta is equal to the adjacent over the hypotenuse. In our case, what represents the cos, the adjacent is the horizontal component. What is representing our hypotenuse is the force that you are being given. So this is the given force. So from there, guys, we can make this the subject, the horizontal component. Remember, it is the one that you want, the horizontal. This is same as over 1, so you can simply cross multiply 1 times this horizontal component. It is going to be horizontal component is equal to these two multiply. So it's going to be F times the cosine of what? The cos of theta. So this is what we have for the horizontal component. It will be the force times what? The cos of theta. So always, when you're calculating the horizontal component, you're going to use what? Cos, F cos. With the same application, guys, if you have to use the ratio of a sine, remember sine, opposite over hypotenuse, we're going to find what? This part of the vertical component. You're going to find it in the same application. So we saw that this will be F, this one. Cos what? Cos theta. So the vertical will be F sine of theta if we are to use the ratio of what? Of a sine opposite over hypotenuse. So make that one the subject. So these are the two that we need. So every time you have the horizontal component, you use F cos, vertical F sine. So guys, this one, let us just take it into consideration like that. So this is not enough. Knowing this is not enough. Knowing this is not enough. So using components, whether you are using the reference angle or not, the horizontal component carries what? Carries cos. So the horizontal component, this is the part of the horizontal. We are talking about what? The x. So some they can call this fx. You'll be looking like calculating as fx. All right. This will be fy. Okay. So that is the case there. So as for the horizontal components, all right. So these ones, they carry what? Cos. So they will be given in the form of cos. H horizontal will be in the form of F cos of theta. So I'm going to explain much into this about the reference angle there. Then the vertical component. All right. As for the vertical components. So our vertical components will carry what? Will carry the sign. So vertical component will be F sine of the theta, which is, like I said, I'm going to explain more about the angle theta there that you're given. So guys, you need to understand the concept there. You find your horizontal components, your vertical components, whatever that you're going to have later on in the simplification, it is going to be determined with the sign that you are having, right? For you to find the resultant and the angle. It depends with the sign. So what am I trying to say about the sign? This is the part that you're going to work about, with in determining the resultant and the angle. Remember, in your mathematics, guys, if something lies in the first quadrant, remember your quadrants. If something lies in the first quadrant, your triangle will be like this, okay? Where this is your angle theta, which is the acute angle. So in this case, in the first quadrant, we can see that the horizontal, this is part of the horizontal. It is what? It is positive. Vertical, it is positive. So this is the condition that will make you to have your triangle in the first quadrant. And here you'll be calculating your resultant and the theta representing what? Our direction, this part. So that is the case. So this is your horizontal component, but it will be positive. This is your vertical component, but it will be what? Positive in the first quadrant. So that is the case. So you have to consider the quadrant that you are working with. So calculating your resultant, you can use, guys, your Pythagoras theorem, horizontal component squared plus what? The vertical component squared in that case. Then for the direction, since you'll be having horizontal and vertical, according to this is opposite, this is adjacent. We saw that opposite adjacent is used on what? Tan from the Torah. So it's arctan. So to find the angle theta, you are going to use what? Arctan of the opposite over adjacent. So opposite is what? The vertical component over the adjacent, which is your horizontal component, opposite over adjacent. So this is what you use as your final answer now to say my resultant is this, and this is my what? My direction. Like I said, theta is for the what? Direction, and this is your resultant that you're going to have. Okay, so meaning this is for the first quadrant, guys. Let's say you calculated and your horizontal was positive, vertical was positive. You are in the first quadrant. You can have your answers in the second quadrant. In the second quadrant, your triangle is going to be like this. And this is the theta, the direction that you calculate. This is your resultant. But what are the conditions which made us to have our triangle in the second quadrant? It is because the horizontal was negative. Our horizontal component, it was a negative answer. The vertical component, it was what? It was a positive answer. This is what made us to have what? Our triangle in the second. So whenever you have your answers like this, horizontal, it's negative. Vertical, it's positive. Your answer will be in the what? Second quadrant. That is where you're going to find what? your final answer. So this is the representation of your final answers. Whenever you're to write your final answers, you need, remember, the magnitude, which is your resultant, and what? The direction. So this is our magnitude, which is what? The resultant. So in the same sense, guys, it can even lie in the third quadrant. So in the third quadrant, how are we going to have our triangle? We're going to notice that our triangle will be like this in the third quadrant. We're going to have our triangle like this, whereby in the third quadrant, the horizontal was what? The horizontal component, it was a negative. This is the negative side. The vertical component, this one, it was also a negative. So these are the conditions which made you to have your triangle in the third quadrant. And this will be your resultant, and this will be your direction, which is the theta, the angle that is in between. And you must also specify according to the pose that you are also having, guys, here. According to the pose, it is also important. Let me just finish up here because someone will be asking this again. What about the exact direction? So in the first quadrant, guys, if you're considering the first quadrant, according to theta, our direction, we are moving. Remember, this is our north, this is south, this is west, this is east. So in the first quadrant, guys, where am I writing? This is the east here. So in the first quadrant, the pose that you have, you're working with the north and the east. So it can be like this. You are moving from the east going to the what? To the north. You're moving from the east going to the north. So it will be east. The angle that you'll be having there is theta. So it's theta degrees going to the what? To the north. This is the condition of what? Your first quadrant. Or it can be another way. You can calculate this one, the angle that is in between here. This angle that is in between. Let's call it alpha. If you are using alpha, you are moving from the north going where? To the east. So if you are using this alpha, you're moving from the north to the east. So it will be north alpha degrees to the what? To the east. This is what you're going to have when you are working from what? The first quadrant. As part of your what? Your direction. If you are working from the second quadrant, guys, as part of your direction, this is where we have our theta here. So we are moving from the west going where? To the north. So it is west theta degrees going to the what? To the north. Or the opposite. You can have it this the other direction, from the north going to the west. But in that case, you must use this angle in between. Let's call this one alpha in between here. So it's north going to the what? To the west. North in the west direction. So it is going to be north alpha degrees there. You use alpha. So it will be west. Alpha degrees to the west. So this is the condition of your direction when your answer is in the what? Second quadrant. This is how you're going to take your direction. All right. In third quadrant, like I said, guys, this is how you're going to have, and your resultant does not change. Your resultant, the formula remains the same. This is the formula for what? Your resultant. But for the direction now, in our case, when it is like this, our direction will be what? Remember, according to our pose. All right. Sorry for that. All right. Remember, this is our north, south. All right. Go to our west and our east here. All right. So in this case, according to the given direction, we are moving from the west. According where we have our triangle, inside the triangle, it is west to the what? To the south. So in terms of our direction, in this case, we're going to have west theta degrees going to the what? Going to the south. All right. Or we can have it either way, the other way, south to the what? To the west. So in this case, we'll be using this one as your what? As your alpha. So it will be south alpha degrees going to the what? To the west. This is part of your direction, this and that. So guys, just make sure you go through your mathematics. This is part I'm not even supposed to be explaining this, guys. This is part of your mathematics. So this is part of the third quadrant. The fourth quadrant, part of the fourth, it's going to be like this in the fourth quadrant. All right. So these are the conditions when your horizontal component was positive and the vertical down here was what? Was negative. When it is like this, your answer is going to lie in the what? In the fourth quadrant. This will be your resultant and this will be your direction. So as we can see, according to our direction in this case, we are moving from the east to the south, east and south, east to the south. So it will be east theta degrees to the south. Or we can move from the south going to the east, which is this angle in between here, this one, which you can call it alpha. So it's like this, from south to the what? To the east. So it will be south alpha degrees to the what? To the east. These are the conditions of what? Of the fourth quadrant in terms of your direction. So guys, this part just, what can I say? Just go through your mathematics because I'm not supposed to be explaining this actually. All right. And also the reference angle. So as you are going to combine, because you need to combine these components. So you're combining, guys, you've got your components now together. But how were you combining now? This is the part where I indicated here using the reference angle now. Using the reference angle, because as you take this angle theta, as you take the angle theta, guys, it must be according to the way, I mean, the theta that you are using, like, is it the actual angle or is it the reference angle? So using the reference angle, guys, we must, what is a reference angle? The reference angle, guys, is an angle, which is, it is an acute angle, this one. It is an acute angle formed between the terminal side of an angle and the x-axis. That's a reference angle. Is an acute angle, this one. Is an acute angle, guys. Like I said, guys, this is our mathematics here. So this one is an acute angle formed between, so it is formed between the terminal side of an angle and the x-axis and the x-axis. So in our case, the x-axis represents what? That is the horizontal. The horizontal. It is the angle that we find between, like, let's say we got something like this. This is your x-axis, which is your what? Your horizontal. I'm not saying horizontal component, guys. I'm just saying it's a horizontal. This is a horizontal line. So when an angle is formed from the, I mean, when a force is being taken from the point of application of the force, it creates an angle between, let's say this is our force like this. It creates an angle between the horizontal and the terminus, which is this one, which is this line, which is it, the force is on. So this will be like this. This is our theta, which is our reference angle. This is your reference angle. If it was in this quadrant, guys, it was going to be like this. The reference angle between the force that you're having and the x-axis, the horizontal. So it is the angle, this one that we have here. This is our reference angle. If it was in the first quadrant, guys, like this, this is your force, this is the horizontal, between, in between. So this is the angle that you have here, in between. If it is in the second quadrant like this, we are going to have the force and what? The horizontal. This is your horizontal, this one, your x-axis. So in between, we are talking about this, in between. This is our theta, in between. So these are the reference angles in each quadrant that you must expect in the first, second, third, and so on. These are the reference angles that we expect to have. So using the, okay, this is our second, our third, remember our fourth. So using the reference angles now, how do we combine our forces? When you are using the horizontal components, your vertical components, but the angle that you are working with is the reference angle, how are you going to take your answers? How are you going to combine them? Whenever you're using the reference angle, you consider the sign of the trig that is in that quadrant. The trig, I'm talking about the trigonometric in that quadrant. In this case, we are talking about what? A sine and a cos. So we must consider in that quadrant that you are in, what is the relationship of a sine and a cos? Those are the two that we consider, remember, for horizontal and vertical. So you must be very careful, guys. As you consider, this is your horizontal, this one. Horizontal, this is horizontal. This side of the horizontal, how do we consider? Is it positive or negative? Horizontally, this side is what? It's positive. This side horizontal is what? It's negative. This is the case of what? The horizontal that we are talking about. This side, it's negative. This side is what? It's positive. But when you are to refer to the vertical you're talking about like this going up. So you can see that the vertical is what? Is positive here. It's up. The same way this side, your vertical is what? Is positive. But if you consider the third quadrant like this, look where your vertical is. It's down below the x-axis, where our vertical is what? Negative. Our vertical becomes negative. This side, our vertical is what? Negative. So this is how you can see from our diagram, or you can consider the trigonometric situation that I was saying about sine and cos. How do you apply this? Remember your cast from your mathematics. So we are considering the cos and a sine. In the first quadrant, all are positive. Sine is positive, cos is positive. In the second quadrant, it's only sine which is positive. Sine is positive, cos there becomes what? Negative. So that's why you see the horizontal is negative. Sine is what? Positive. Remember, sine for vertical. In the third quadrant, it's for tan. So it means both will be negative in this quadrant. Both what? Sine and what? Cos. Sine will be negative, cos will be negative. That's why you see in the third quadrant, it's only negative. Horizontal negative, vertical negative. It is because of this. The fourth quadrant is for cos. So meaning to say cos is the one which is positive. What about sine? Sine is negative. So that's why we see our sine being what? Negative there. So when you are using the components, guys, you must consider, when you are using the reference angle, this one, you must consider the sine. What is the sine in that quadrant for the horizontal? What is the sine in that quadrant for the vertical? You're done. This is the condition. So we are going to have another class where we'll be using the actual angle. So here we are using what? The reference angle. So we're simply going to have a continuation on this part, but using the actual angle. So for us not to have confusion, this is what we're going to have, guys. Let us just have a question and example. I didn't want it to be much extended like this, but anyways, let us just see just a typical example on how to apply these components using our reference angle. Take note, you are using what? Reference angle in calculations. You can use the actual angle. That will be for another class. So let's say we are given to find the magnitude and direction. Find the magnitude and direction. All right, the magnitude and direction of the resultant. So we're going to have the resultant of the following. All right, of the following system of forces. All right, system of forces. So this is what we have. So I'm just going to have typical questions, guys, where already the diagram is already drawn. So let's say we've got something like this where we have the vertical and horizontal just being given like this. Then they will give you actually something like this. Let's just hope it is not going to be that much. All right, then they'll give you something like this. And okay, let's say something like this and another one like this. Okay, so these two forces that they're being taken from the point of application of the force. So the first one lies directly in our reference in the horizontal. So the reference point, according to our angles, guys, as we take our angles in the reference here, it will be at 0 degrees. All right. So that part, you're supposed to know it, guys. Okay, no problem. So this is it. We are given two forces on our example. This is 40 Newton. Another one is 30 Newton. And the angle in between these 2 points is 30 degrees. All right, so that is our question. We are asked to find the magnitude and direction of the resultant of the following system of forces. And this is what we have. So there we've got two forces that we are going to combine using our components, and not only using the components, but focusing on the reference angle. Focusing on the reference angle. So like I said, when using the reference angle, we must take the angle, which is the acute angle formed between the terminal side of an angle and the x-axis, which is what? The horizontal. So according to this, guys, this one is directly in the vertical. If you see these dotted lines, they simply show you something like this to say this is north, south, west, is like that. So they can show you in form of what? The dotted lines, or they can actually indicate it properly, north, south. So this part here, the dotted lines, they are a continuation of this line. So what does it mean? It means this line is directly, or it is directly in the east. This is the east. It is directly on the horizontal, on the 0 degrees, on the reference. This is where it is. This is your horizontal. It is directly on that horizontal line, guys, directly on our x-axis. That is the case of our angle, I mean, of this force. So it is at 0 degrees. Then this one for 30 Newton, the angle is 30 degrees. And we can see that this angle is between the horizontal and the terminal, between this force. It is in between. So that means this angle that we are having here is a reference angle, guys. We have a reference angle there. Between, it must be between the force and the horizontal. So once you are using the reference angle, guys, as long the angle is between the force and the horizontal like this, and these forces, they are taken away from what? From the point of application of the forces. So there's no need for us to make any adjustment here. Once we have this, we are going to calculate our components. So horizontal components, you sum up everything that you see in the horizontal. So there is a 40 at an angle of 0 degrees. All right, that one you can write it, guys. Remember, horizontal, I said it carries what? Cos. Wherever you see horizontal, it carries what? Cos. It's the force and the cos vertical sign. So that's cos 0 degrees. All right. So using the reference angle now, we must consider, this is, guys, as you can see, this is positive, all right? I did not mention that, but we must consider that this is the positive side of the horizontal, positive. Vertical is this side, which is what? Negative. So anything that is this side, the right side, anything that is on the right side, as long it's horizontal, it's positive. So it means that will be positive 30 cos of the angle in between. So that's 30 cos of this angle in between, which is what? 30 degrees, just like that. So this will be the condition of your question, guys. So I want you to use your calculator, combine everything. That will be 65, 981 Newton. Then you must consider the direction. Horizontal, it can be, if you are considering horizontal from this point, guys, it can be you are going this side or you are going this side. So positive, negative. Positive, which side are we going? This is the east. Remember, that is east-west. So whenever it's positive, that is to the east. All right, let's look into the vertical component. So the vertical component, it carries the sign, remember, sign of theta. But using the reference angle, we must consider where it is. So this one, guys, it is on the reference. It lies on the horizontal. It cannot be a vertical. But if you want, you can just write as what? 40 sin Z. But there's nothing there. There's nothing to consider. A horizontal line is not a vertical line, guys. In this case, like this one, it's a straight vertical, I mean a straight horizontal line at 0 degrees. But if you want, you can just write at 0 degrees like that, like I said. Then you consider the 30, where it is below this horizontal line, below the x-axis. The vertical is what? Is negative. Above, it's positive. So as we consider below, anything that is in the vertical is what? Negative. So like I said, guys, when you are using the reference angle, you must consider the sign there. Or you're considering you're dealing with what sign? In the fourth quadrant, sign is what? Sign is negative. So it carries a negative. So that's negative 30. Sine of what? Sine of 30 degrees. So this will be your vertical component. So combining this, you're going to get negative 15. Vertical, vertical, as you are comparing, going up, positive, negative. That is north, south. So we have a negative. So it means this vertical component of ours, it is going to the what? It is going to the south. So that's 15 Newton, which is going to the what? To the south. That is the case of our question. So we have east and we have a south. On the combination, so guys, you see the acute angle. You must consider the sign. Most of you guys, you want to use the acute angle in your calculations. It's fine. But be careful because you must consider where is it found. All right. Then moving on now to the calculation of the resultant, like I was explaining this part of the resultant now, we must consider which quadrant are we in this case. Which quadrant are we going to have our resultant? Which quadrant? So in our case, we have a quadrant. Our quadrant is going to be what? Horizontal is what? Positive, remember. Vertical is negative, this one. So this is the quadrant that we want, where horizontal is positive and vertical is negative, or where we have east and south, according to this pose. Where is it that we have what? The east and the south. You're done. This is your north, this is your south, this is your west, this is your east. So where is it that we have the east? Like I said here, the east and the south. So east and the south, meaning to say this is the quadrant, the fourth quadrant. Or where do we have horizontal positive, vertical negative, horizontal positive, vertical negative, fourth quadrant? So in the fourth quadrant, this is how your triangle is going to be, like guys, I explained this. So you're going to take our triangle to be in the fourth quadrant. So in the fourth quadrant, our triangle will be like this. All right. So where this is a right angle and this is our direction, theta. This is our resultant. So this is the horizontal part. So horizontal, it was what? 65.981. The vertical is negative 15. So you can write this negative 15, guys, or you can simply ignore it. The negative is just showing us we are going down. But in our calculations, we just use what? The positive value. There's no need for us to have what? That negative in calculation. So that's it. We can calculate our R and our theta. As we saw, guys, from Pythagoras theorem, R can be calculated the square root of what? Horizontal component squared plus vertical component squared. So we can calculate our R from there. That will be the square root of, so let's quickly have this horizontal component plus vertical component squared. So our R is going to be the square root of 65,981 squared plus the vertical component, which is negative 15. Like I said, you can even ignore this negative. It is not even important in your calculations. So that was it, guys. Make sure that you use your calculator properly. That's 67,665, which is resultant is always positive, guys. All right. Remember, these are newtons. So our answer is going to be newtons. Then we calculate theta, which is the direction. So our theta is going to be arctan of the opposite according to this theta, guys. This is your opposite. And this is our adjacent, vertical, horizontal. So that is arctan of the vertical component to the horizontal component as we had our formula here. So that is it. So we can substitute in this case. All right. Sorry for that. Let us substitute our theta is going to be what? Arctan of the vertical of horizontal. Remember, we have this, guys, vertical, horizontal, but you just take as they are positive values, not with the negative. You take them as they are positive, only positive, okay? So that part is already explained, guys, in terms of the reference. So you just take positive. So it's 15 over 65.981 as what? As positive as they are. All right, so that was going to be 15 over 65.981. Remember, this was 65.981, like this. So that was going to give us the value of theta, which is 12,808 degrees. The direction in the what? Fourth quadrant. We are moving from where? East to the south. Or it is south to the what? To the east. So this is what I was explaining now in terms of this. The fourth quadrant here, it is either we are moving from east to the south or from the south to the east. If you are calculating south to the east, you must calculate the alpha, which is this angle that is in between there. This one. If you want, you can calculate this angle that is in between this alpha here for the direction. So for you to calculate alpha, remember this is a quadrant. Quadrant divided into 4, guys. This is 90 degrees. So alpha can be calculated from the 90 minus what? 90 minus theta. So meaning to say our alpha is 90 minus our theta. Remember we said theta, we got what? 12.808. So that's 12.808. 12.808 degrees. So that's our alpha, which was going to be 77.192 degrees. All right. So let's finish about theta first, then we'll come out to this alpha. Let's finish about theta. So in terms of theta, this is how you're going to write our final answer. So what are we saying here in terms of our theta? So in terms of the theta, we are simply saying, therefore, our resultant in that case, R is going to be what? The one that we got here, which is 67,665 Newton at the direction now. Theta, according to theta, is affecting from east going to the what? To the south, east to the south. So it will be at east theta degrees, which is 12,808 degrees, going to the what? Going to the south. So this is when you are using theta. If you are using this one for alpha, you are moving from south going to the what? To the east. So the direction will be south, this angle, 77,192 degrees, going to the what? Going to the east. This is how you can also have your answer as when you are using the angle alpha. Just like that. So this is how you simply apply your components. So you must consider the part that you are working with. Is it to say you are having, in this case, are you having in terms of the reference angle that you are working with? The reference angle, where is it situated? It affects your vertical, horizontal. Where is it situated? Is it going to carry a negative? Is it going to carry a positive? If it was in the second quadrant, your horizontal was going to carry a negative, vertical was going to be positive. So whenever you're using this form, guys, of the reference angle, be very careful. Which quadrant do you have? Apply the sign that affects your vertical or horizontal according to the sign. The sign is supposed to be used. Then you calculate, guys, your result in this part now. After calculating your components, horizontal, vertical, use them now on this final diagram that is to have the final say to say, is it going in the west to south? Is it west to north? Is it north to west in terms of the direction? The resultant, yes, we can even calculate it here. You can find your resultant there. But in terms of the direction, it is important that you do a sketch. You need to know what is happening in each quadrant in terms of your direction, like I was explaining here, to say in the first, these are the directions that we are going to expect to have. In the second quadrant, this is what you're going to expect to have in terms of our second quadrant. These are the ones that you're going to expect to have. In terms of the third quadrant in our direction, this is what you're going to expect to have. In the fourth quadrant, this is what you're going to expect to have. So let's revise this, and we are going to have another class actually using the same components, but we'll be using the actual angle. There's a difference between the reference angle. The reference angle, it is the angle which is the acute angle formed between the terminal side of an angle and the x-axis and the horizontal in between horizontal and the force that you'll be given. So if you're working with N4, like I say, those speed in meters per second, kilometers per hour, if you are using components and you are using the reference angle, this is how you're supposed to take your answers. Check where are you having that component, positive or negative. All right, so let's meet guys in the next class using the actual angle so that we just notice the difference on how to apply in our calculations.